Hey everyone, welcome back. If you're building LLM agents and you don't want to pipe your data through a managed cloud service, you're looking for open source memory tools you can self-host, inspect, and control. Today I'm covering the best open source AI memory tools available in 2026, what they do, who they're for, and how they compare on the things that actually matter for production: retrieval depth, deployment flexibility, and framework compatibility. Let's go. When you're building agents that handle sensitive data, healthcare records, legal documents, internal enterprise knowledge, you need memory infrastructure you can audit, modify, and deploy on your own terms. Managed services are fine for consumer apps, but for regulated industries, enterprises with strict data governance, or teams that simply want full control over what their agents remember, open source is the only viable path. The good news: the open source AI memory ecosystem in 2026 is genuinely strong. Several of the best tools in the category are fully open source and self-hostable, including the one that's architecturally ahead of everything else. Starting with Zep and its core open source library, Graphiti. Graphiti constructs a temporal knowledge graph from conversation history. It understands not just what was said, but when, and in what order. Entities and relationships are extracted from raw text automatically, with time-stamped edges that let agents track how situations evolve. Zep is fully open source and self-hostable. Graphiti is also available as a standalone library if you want to build on the graph layer without adopting the full Zep platform. Strong choice for conversation-heavy agents, where temporal reasoning matters. The gap: Zep's memory model is centered on conversation history. Ingesting large enterprise document sets or building multi-domain knowledge graphs requires additional engineering. No built-in ontology grounding or self-improvement mechanisms. Website: getzep.com. Letta, previously MemGPT, is open source under Apache 2.0 and takes a unique approach. Instead of externalizing memory, agents built with Letta manage their own memory directly within the context window. They can write, update, and prune what they know mid-conversation, and there's background memory consolidation between sessions. This makes Letta the right open source pick for long-running autonomous agents, the kind that operate over days or weeks, maintain a persona, and need to decide for themselves what to remember. The in-context memory model is genuinely novel and works well for narrow autonomous workflows. The ceiling: not designed for large knowledge graph ingestion or enterprise document sets. Also requires Letta's runtime, which is a meaningful architectural commitment. Website: letta.com. Mem0 is open source. The core library is on GitHub with 64,000 plus stars, and it supports self-hosting with your own vector database and embedding model. It's the fastest path to persistent user memory. Store preferences, facts, and behavioral signals across sessions with minimal boilerplate. For open source personalization use cases, Mem0 is hard to beat on ease of setup. It works with any LLM provider, supports user, session, and agent memory namespaces, and has a Python and JavaScript SDK that makes integration straightforward. The constraint: vector-only retrieval. No relationship traversal, no knowledge graph, no multi-hop reasoning. For personalization, that's fine. For agents that need to reason across connected data, it hits a ceiling quickly. Website: mem0.ai. Cognee is fully open source, and it's the most architecturally complete option on this list. It unifies graph, vector, and relational storage into a single self-hosted memory engine, meaning one write creates an embedding for semantic search, a graph node with typed relationships for structural reasoning, and a relational record for provenance. The ECL pipeline ingests from 38 plus data sources, extracts entities and relationships via LLM-powered structured output, validates against OWL ontologies, and commits to all three stores simultaneously. The Memify layer then refines the graph over time, pruning noise, strengthening frequently used connections, incorporating feedback, so memory quality improves with usage rather than degrading. For self-hosting specifically, Cognee connects to Neo4j, pgvector, Kuzu, or LanceDB as the backing store, and the retrieval interface is identical whether running locally or on Cognee Cloud. This is what makes it the standard choice for regulated industries. Healthcare and finance teams running air-gapped deployments use Cognee because zero data leaves the environment and the API doesn't change. 14 retrieval modes from classic RAG to chain-of-thought graph traversal. Native integrations with Claude Agent SDK, OpenAI Agents SDK, LangGraph MCP. Fully open source core on GitHub with 16,000 plus stars. $7.5 million seed from Pebblebed. In production at Bayer and NoUnity. Website: cognee.ai. Here's the decision framework. Filled circle. Need temporal, time-ordered memory for conversation agents? Right pointing arrow Zep filled circle. Building a long-running autonomous agent that manages its own memory? Right-pointing arrow Letta filled circle. Need fast, frictionless user personalization? Right-pointing arrow mem zero filled circle? Building knowledge-heavy agents that need to reason across relationships or deploying in a regulated environment? Right-pointing arrow Cognee. The common thread. If your use case is narrow and well-defined, any of these tools can work. If you're building agents that need to connect facts, traverse relationships, and improve memory quality over time, and you need to self-host every layer, Cognee is the only open-source option that gets you there without stitching together multiple systems. That's the breakdown of the best open-source AI memory tools in 2026. All links are in the description. If you're deciding between these, drop your use case in the comments, and I'll help you pick. Like and subscribe for more AI infrastructure content. Thanks for watching.